All right, we have 5 marks here on the required practical for enzymes. So we've got a method which is slightly different to the normal one we're used to in this topic. So a scientist prepared amylase solution at optimum pH and they mixed the amylase with starch in a boiling tube. So think about what's going to happen here. Amylase, remember, is the enzyme that breaks down starch into sugars. Step 3. They measured the concentration of sugar every 10 seconds for 2 minutes. So the way we're usually taught this required practical is we don't measure the sugar, we measure the starch. We use iodine solution, and the point at which starch stops being present, we say that the amylase has broken it down. This is the other way around. We're measuring how much sugar is present. So once the amylase starts working on the starch, sugar starts getting produced. So it'll start off very low. You'll start off with no sugar because it's all starch. And then as the starch gets broken down, the level of sugar will increase. So that's what's shown in this graph here. We start off with 0 and then it increases up with a curve. It eventually plateaus at the end here. How much time did it take for the amylase to digest all the starch? That's the first question. So to find that out, you want the point at which the graph becomes flat, because at that point, there's no more increase in sugar. So that means you've had your maximum amount of sugar being produced from the starch. All of the starch has been broken down, so there's no more to be given. So that would be around this point here. So you'd need to read that off. I would try and use a ruler to make sure you read it off, draw a line. And if you read that carefully, that's around 82 seconds. It's just 1 square to the right of the 80. 10 squares is 20, so that means 1 square is 2. So that's 82 seconds. Next part says determine the rate of sugar production per minute at 40 seconds. Okay, so this is a tricky one. Let me rub all of this out first, because to find the rate, what you need to do is find the concentration over time. Rate is how fast is the reaction happening. So if you have a graph of concentration against time, to find how fast this reaction is happening, you need to find how steep the line is. The steeper the line is, the faster the rate. This comes up in chemistry as well, in a rate of reaction graph. The steeper the line, the faster the rate. That's why right at the end, it goes flat because the reaction has stopped. Right at the beginning, the reaction is very fast because it's very steep. We want to find out how steep is it at 40 seconds, it says in the question. So how steep is it if 40 seconds is here? How steep is it at this point here? How do we find the gradient? So gradient is usually found by doing change in y over change in x. It's easy for a straight line. You just draw a triangle, you find the change in y and you find the change in x. It's harder for a curve like this because curves don't have a constant gradient. We want a gradient at that particular point. To do that, what we need to do is draw a tangent. So a tangent is a line which only touches that one point and is the same steepness as that one point. So what you'll do here is you'll get your ruler and you'll basically rotate it so that it touches that one point and it's roughly the same gradient as that point. Okay, so once you've done that, you can draw a line. That is your tangent. What do we do with this tangent now? We need to find the gradient of that tangent. What is the easiest way to do that? So you need to do what you normally do for a straight line. You draw a triangle, find the change in y over change in x. So let's try that out. Let's try and pick some easier numbers to work with here. So I'm going to draw a large triangle here. The larger the triangle generally, the more accurate your answer is going to be. So I'm going to make it go to 5 because that's a nice round number. And I'm going to make it go all the way to the starting point so that we can work with easier numbers here. Okay, so if you draw your own tangent, it probably will be slightly different, but that's okay. In the mark scheme, they usually have like a range of values you can have. As long as your method's right and you're picking the right numbers here, then you're going to get the marks. So let's try and use my numbers here. We need to work out the values. So change in y over change in x. So change in y is the height of that triangle. So it ends up at 5. We need to know what that starting point is. I'd say it's about 2 small squares below 2. So that's 1.8. So the change in y will be 5 minus 1.8. Now, to find the change in x, that's the horizontal length, we're starting off at 0 here. We need to find out what this is. So it's going to be something minus 0. Let's work out what this is. This is about 2 squares to the left of 80. Remember, on the x-axis, I said each square was worth 2. So that would be around 76. So if you work that out, you get an answer of around 0.042. That is the change in concentration over time. So that would get you 3 out of the 4 marks. Why is that? Because it specifically says per minute. What we've done here is per second because the graph is in seconds. We need to convert that into per minute. So if it's 0.042 per second, per minute is going to be much bigger. There's 60 seconds in a minute. So that's going to be 0.042 times by 60. And that gives an answer of 2.5 arbitrary units per minute. So that's your answer there. So remember, loads of people will get different answers here because it all depends on how you draw your tangent. You're going to be drawing it slightly different to each other. But if you get your method right, then it's fine. So try and use a triangle which is as large as possible to try and get the most accurate mark there. And there you have it. That's 4 marks.